we want to move to the third theorem. It is simply angle in a semicircle. There is nothing to talk about here, but you remember your angle at the center is twice angle at the circumference? Definitely that's what we are going to use here. What do this mean? What does this mean? We have anytime you have a diameter here, then you are good. Anytime you have, that's the hint for this theorem. Anytime you see a diameter, then you should locate something. If this is the center, that's zero. Definitely this is a diameter. So once you have any shape like this from either here or here, then you have this theorem. Why is it related to angle at the center being twice angle at the circumference? You know the angle here is 180 degrees. So definitely if this is 180 degrees, it is said that this is automatically 90 degrees. So once you have a diameter, then it is obviously 90 degrees. So it can be anywhere. It can be this, it can be this joined this way, it can be like this joined this way, it can even be this joined this way, it can as well be this coming this way. So this is 90 degrees, this is 90 degrees, this is also 90 degrees, then we have 90 degrees here. So they call it angle in a semicircle. Angle in a semicircle. Alright, I think we should check this theorem first. That's the first theorem before we combine the angle in the semicircle alongside with this one to have classwork. Let's quickly check this through because we are using angle at the center is twice angle at the circumference for these two. So let us see how it goes. I think I almost did it the other time, but we need to look at it in another angle. If you have, for instance, I have my center. Of course, I will always have my center. Then with this, if I connect this one to this, that is angle at the center, sorry, angle at the center is twice angle at the circumference. I can have this one connected to this, I have this connected to this, in fact this connected to this. So if this is what I have, definitely if this one is angle at the center, if this one is 50, then this one is 25. Angle at the center is twice angle at the circumference. This is obviously 25. Angle at the center is twice angle at the circumference. This is as well 25. Angle at the center is twice angle at the circumference. And this is 25. Angle at the center is twice angle at the circumference. So in order, instead of we to be using this angle at the center, we can just say this one is equal to this, and this one is equal to this, and this one is equal to this now. So we call it angle in the same segment. Angle in the same segment. How does this work? Follow me please. If I have a circle, if I have sorry, let me bring it down a little bit so that you can see. If I have a circle and I have this symbol in it, any way it is written, it could be this, it could be this way, anyway, there is definitely angle in the same segment there. So this angle x will be equal to this angle, and this angle will be equal to this angle. That is angle in the same segment. This one, we can call this m, it will be equal to this m, that is angle in the same segment. Likewise this one, n, will be equal to this one, n, angle in the same segment. It doesn't matter how it is drawn. I can redraw it to be, it can be drawn in a scattered way. It can be like this, can be like this, it can actually be like this. So far this is at the circumference, then this angle is equal to this angle is equal to this angle. In fact, let me redraw in another way that is very unreasonable, which will be the same thing eventually. I can have this. Funny? Yes, this angle is equal to this angle, this angle is equal to this angle. Can you see it? Interesting. So that is the fourth theorem. So let's apply theorem 3 and theorem 4 now. Let's see how it goes. Okay, now let's check this question. Let's look at it. What are the theorems you can see there? Let's check the theorems out. I can locate a diameter. This is a diameter. Definitely there is angle in the semicircle. That is, this will be 90 degree. 1. And as well, I think this angle is going to be equal to this angle in the same segment, and this alone will be equal to this as well. That is angle in the same segment. So once we have this, we are good. The question, yes, this question is they put 35 degrees here. That's the question. So if 35 degrees is here according to the question that I didn't write there, then I can have my, first of all, I can have my R, that is P R Q. P R Q, that means this angle, P R Q, this angle will be equal to 90 degree. 90 degree. Why? Just say semicircle. You're good. So if this is 90 degree, then we have this one as well to be 35. So my angle PQR, that means this PQR is equal to 35 degrees. Then what were we asked to find? RPQ. This is R, P, and Q. This is the question we were asked to find. This side, this angle. So RPQ. RPQ. That means angle P. So from there, so far we can locate 35 degrees. This is 35 degrees. So I think this is a triangle. I'm sure this is a triangle. So we have 90 degree here already. So definitely 35 minus 90 will give us this. That means what supplements 35 now? You know this is 90. So these two angles will definitely be 90. That's complementary angle. So what complements 35 now? So sorry, not supplement. What complements 35? That is 90 minus 35 degrees will be equal to RPQ. That is 55 degrees. That's 55. So this angle is 55 degrees. That is that for the first question. We are good. Going by the second question now, we have RP. We are finding RP. That means this line, that is a line. If line PQ, this line is 15, and QR, that is Q and R, is 8. Looking at this, so far we have a 90 degree here. So we are, that means that shape is a right angle triangle. That shape is a right angle triangle. Where this is your right angle with R, then we have your P and your Q as the case may be. So my PQ has been dedicated to be 15. Then my QR, that means QR, is said to be 8 centimeter. So the question asks us to find this one. I can call it Y now. To find this one, then Pythagoras theorem goes. So easily, so we can have, so don't forget the law of Pythagoras here. Hypotenuse, that is 15 square, is equal to y square plus 8 square. So that's all. So we have 15 square minus 8 square is equal to your y square. So 15 square is 225, and 8 square is 64, equals y square. This is going to be 1 from 12, that is 6, and 1, that is 161, is equal to y square. So we root both sides to remove this square. So we have y to be, that's 169, 144. So this is a 12 point. It's 12 point. 161 is close to 169. So I can say 12.68 something. Or yes, yeah, it should be 12.6, around 12.6, 12.7 or so centimeters. That's all. So that is the end of the combination of the third theorem that says angle in the semicircle, and the fourth that talks about angle in the same segment. So same segment, angle in the same segment are equal, and angle in the semicircle is equal to 90 degrees. We have this shape. Here is 28 degrees, here is x degrees, and you are solving for x actually. Let's see how you can do that. Then this is 110, this is 110, this angle is 110, then this angle is 30, and this angle is Z. You can label it if you want. I can call this one A, call this one B, a C, a D, and I can give this one E. and I can call this one X and Y, and Z. Forget this one is A. So don't forget to send your answers to my WhatsApp page. Let's see how you have learned. Then you can snap it, you can screenshot it, you can any medium. Just make sure you see you can send your anything. You can send your comments on WhatsApp and on the YouTube page, so we know how far you are growing. So if you have questions, please don't be afraid to bring it up. Thank you. You can send your classwork to the WhatsApp page that is scrolling on the screen there, so we can see how you are growing. And if you have questions, please don't be afraid to bring it up. You can send it to the WhatsApp page. You can talk about it on the comments. You can comment on it. You can discuss, so that we can discuss everything together as we grow. Thank you, and thanks for listening.